Alright, hi everyone. Today in this video we'll be talking about L'Hopital's rule, and this is pronounced L'Hopital. You don't say the H, and sometimes I think it's too complicated, so I'll call it LHOP at times, but it's called L'Hopital's rule. And L'Hopital's rule states that if you have a limit as x approaches any number, we can call C, any real number C, and you have f of x on top, divided by g of x on the bottom. If this is indeterminate, how about indeterminate? This is probably wrong, but that doesn't matter. If it's indeterminate, meaning 0 over 0, or infinity over infinity, or negative infinity over negative infinity, or negative infinity, okay, so that means it's indeterminate. And if that's the case, then the limit for this, if it's indeterminate, then you can simply take the derivative of the top and divide it by the derivative of the bottom. No, you don't use any chain. You might need to use chain rule, but you should not be using quotient rule to divide both of these as a whole. It just simply the upper part, take the derivative of that, divided by the bottom part with the derivative. Okay, it's really simple. Just if you have a limit to any number and you have equal to 0 over 0 or infinity over infinity, then that's indeterminate, and then you can use L'Hopital's rule. You write LHOP applies. Then you write this. So in a real problem, you'll write the limit as x approaches, let's say any number 2, of let's say x squared over 2x. It's 0 over 0, right? Then you write equals, if this is, you're shown as this is a problem, you write limit as x approaches 2 of x squared equals 4. No, 4 over 4 is not 0, 0. Crap, my bad. So let's write, let's put 0 here. Let's put 0 here. There we go. Limit as x approaches 0 of x squared equals 0. Of 0 squared is 0. So, and also limit as x approaches 0 of 2x is also 0. And then you write, hence, L'Hopital's principle. L'Hopital's rule, it's a rule, not a principle. LHOP applies. And then you can write the derivative of the upper part, x squared is 2x, and you can write lim as x approaches 0 of x squared over 2x. The derivative of the top will be 2x, the derivative of the bottom will be 2, you plug in 0, and then 2 times 0 is 0, 0 over 2 equals 0, and that's your final answer. Limit as x approaches x squared over 2x is 0. Alright. That's an example of the work you need to show on FRQ to get full credit. You need to first write the limit of the top and the limit of the bottom. If they're both 0 or if they're both infinity, then you write L'Hopital's principle. L'Hopital's rule applies, and then you show your work for the derivative. Okay, now we have a worksheet, and I found it by searching this up. Should be the first link on CD Schools, and then here's the worksheet. Okay, so we'll be doing a handful. Let's only do the odd ones, alright? Actually the even ones look harder. Why the even ones all tangent? Okay, we'll start with we'll do the even ones. So if we first have limit x squared plus 3x minus 4 over x minus 1, and although this says L'Hopital's practice, we first always use direct substitution. Only when we use direct substitution, we plug 1 in and find out that it's 0, and then 0 infinity, only then do we start using L'Hopital's rule. So if we plug 1 in, 1 squared is 1, 1 plus 3 is 1, 1 plus 3 is 4, 4 minus 4 is 0, 1 minus 1 is also 0, and I don't have room, but if you do have room, you'll be writing lim of x squared, all that thing, equals 0, and the lim of x minus 1 is 0, and equal to 0, and then hence L'Hopital applies and stuff. But I'm not going to do all of that, because I have very limited room here. So let's take the derivative of the top, and then derivative of the top will be 2x plus 3, derivative of the bottom will be 1. Plug 1 in, 1, 2, 2 times 1 is 2, 2 plus 3 is 5, 5 over 1, which is 5. So number 1 should be 5, and the answer key is on the bottom. Oh shoot, number 2, yep, number 2 is 5. Alright, next one, tan of 0 is 0, 0 plus sine of 0 is 0, 0 over 0 is 0. Okay, 0 over 0 is indeterminate. So this one, L'Hopital applies. So derivative of tan is secant squared x. On the bottom, 1 plus cosine x. Now plug 0, secant is 1 over cosine x, and cosine at 0 is 1. So on top it will be 1 On the top is going to be 1. My pencil. 1. On the bottom, cosine x is 1 again. Cosine of 0 is 1. 1 plus 1 is 2. So number 4 should be 1/2. Like, also, you should have your unit circle memorized, but that's from pre-calc. So hopefully you still remember. You need the unit circle to be able to do quick math, like what I did just now. Okay, so x is 0. Tan x is also 0. Sine is also 0 on bottom. L'Hopital applies. 1 plus secant squared x over cosine x. Secant is 1 over cosine. 1 over cosine 1. Okay, 1 over cosine squared is going to be 1. 1 plus 1 on top is going to be 2. 2 over 1. So number 6 should be 2. Okay, I might... Okay, for this one, let me work it out, just in case there are a few of you out there who doesn't know, who might be a little bit complicated, who got a little bit lost over there. So first, we have plug 0 in. X of 0 is 0. Tan of 0, tan is sine over cosine, and because sine of 0 is 0, 0 over anything is going to be 0. Sine over here is 0. Yep. So now L'Hopital applies. Derivative of x is 1. Derivative of tan x is secant squared, and derivative of sine is cosine. Now we plug 0 in again. Plug 0 into secant squared x. Secant is 1 over cosine squared x. And if you plug 0 down there, cosine of 0 is 1. 1 over 1 squared is 1. So up here is going to be 1 plus 1. So up here is 2. Up here is 2. Cosine of 0 is just 1. So it's 2 over 1, which is how I got 2. 2 as the answer. Alright, let's go find a harder one. Alright, this is an example of yesterday which you would have done reciprocal, right? You would multiply by the conjugate. This is only that you would multiply by the conjugate. You would multiply this by t to the 1/4 plus 2, and the same thing down there, and you'll do all that weird math, but we don't need to do all of that because we can just use L'Hopital's rule. So where is this? So t to the 1/4 minus 2 over t minus 16. Let's plug 16. 16 minus 16 is 0. 16 to the cube root of 4. 2 to the 4th power is 16. 2 minus 2 is 0. So it's 0 over 0, which means L'Hopital applies. Now we use power rule. Power rule is 1/4. We'll make this 1/4. T to the negative 3/4 minus 2. Oh, no, the 2 is gone because of we're taking the derivative. And on the bottom, it's going to be 1. So that's it. On top, it's going to be 1/4 to the t to the 3/4 power. Now if we plug 16 in, 16 cubed is 4,000. Oh, here, wait. No way. The answer is just, you plug 16, it's not that difficult. Okay, number 10. Okay, so 16 1/4 times 16 to the 16 cubed to the 4th power. Technically, if it's an alpha cube, you don't have to simplify it, but this is the same thing as saying, let me think. Okay, I'm gonna have to use a calculator for this. 16 cubed . Okay, yeah, so if you use a calculator, this will be 8. 1/4 times 1 over times, this 8 will be on the bottom, by the way. It's negative 3/4 on top, that's why. So this will be on the bottom, so it will be 1/8. So all of this should be on the bottom. I should not have written this. I should have wrote it like this. 1/4 times. There we go. Try to figure out my work, but the answer over here is this. 4 times 8 is 32. 1/32. Yep. Okay, 2 to the x, we have not learned how to take the derivative of that yet, so we'll put that on hold. Okay, this one requires chain rule. Let's work on this real quick. So sine squared x is just sine x to the squared. Derivative of that will be 2. Okay, first we plug 0 in. 0 of sine is 0. And 0 of 10 is also 0. So now L'Hopital applies. Now we take the derivative of the top. It will be 2 sine x. Derivative of sine x is cosine x using chain rule on the top. On the bottom, we have 10, which is 10x squared. 10x squared, which will be, oops, let me write it here. 10x squared. And this will simply be 2 10x. Reminder on chain rule, you treat this as g of x, and then take you take derivative of f of x with respect to g of x. So our f of x in this case will just be 10x, and then f of x will be x squared, and g of x is 10x. And now we took the derivative outside, we take derivative inside, which is 10x. Derivative of 10x is secant squared x. Okay, now we can plug 0 in. On top, sin x is 0, so on top is 0. On the bottom, tan x is also 0. So secant is 1 over cosine 1, tan x is 0. So that means it's 0 over 0, and we're not done. If you meet across this case, that simply means, okay, I either did something wrong, or this means we keep going. This means we keep going. We take L'Hopital's rule. We use L'Hopital's rule again on all of this. Okay, now as things starts to get a little bit harder. So we have two derivatives. That's a coefficient we're leaving in the front. Sin x is cosine x. Derivative of sin x is cosine x. Cosine x times cosine x is cosine squared x. Times, we leave sin x alone. Derivative of cosine x is sin x. This becomes a negative in front. And on the bottom, okay, I'm pretty sure. Oh shoot! I see what I did wrong. Okay, it's not 10x squared. It's 10x squared in parentheses. Okay, that means now our g of x is x squared, and our f of x is 10 of x. So that means we take that would be secant squared of x squared times 2x. Okay, now there we go. Secant squared is just 1 over cosine. Now why do we still have a sin x on top? 2 sin x. Sin x will be 0, right? So this is number 16. Let me check. 16 is 1. What? Let me see what I did wrong. Okay, we take L'Hopital's rule again. Put here, because it's still 0 over 0. When we plug x in here, it still be 0 over 0. Yep. Let's try that. Okay, so if we plug x in here, sin of x is 0. 0 multiplied by anything will be 0 on the top. Over down there, 2x times 2 times 0 is also 0. So down there will also be 0. And so it's 0 over 0 again. So this is indeterminate, which means LHOP applies again. So every single time you get to an indeterminate, you just keep using LHOP until you actually get your answer. Now we take the derivative of all that. 2 on the top will be cosine x, like we just did earlier, times sine squared x. Put a negative sign. Where's my negative sign? Negative sign. And then it's oh, on the bottom it's gonna be secant squared x. Okay, so this will be 2 secant x squared times derivative of secant is secant x 10x. Secant x 10x, and it'll be x squared for all of these, times 2x times 2. Plug 0 in is 0. Plug that in is also 0. So now in this case, we most likely did something wrong. So let me go down and check the answers. No way, I should not be doing something wrong. What? Oh, okay. 2 sin x. 2 and the 2 cancel each other out. Sin x over x is 1, because derivative of sin x is cosine x, and the derivative of x is 1. So cosine x, that's 1. Let me explain this again. Alright, sin x over cosine x. Sin x over x. When you have limit as x approaches 0, when a limit as x approaches 0 of this, sin x is 0, x is also 0, so L'Hopital applies. Derivative of sin x is cosine x, derivative of x is 1, so cosine of 0 is 1, 1 over 1 is equal to 1. So that's why these two cancel each other. That's 1. So these two cancel each other out. Sin x divided by x is just 1, like what we did over here. And now we just have cosine x times, okay, that's very smart, because now we don't have to use L'Hopital over and over again, and which leads to the wrong answer. So this is why your trig identities are important. You divide just sin x over x, and you need to be able to recognize that that's equal to 1. There are two things that you need to memorize. So sin x over x is equal to 1, and there's another one that has to do with cosine. Let me see if I can find it. There's another rule that you need to remember. Okay, found it. It's limit as x approaches 0, and the same for this, limit as x approaches 0. That's a limit. Okay, 1 minus cosine x over x is equal to 0. Again, if you want to prove this, this is the same way we use L'Hopital. Cosine of 0 is 1. 1 minus 1 is 0 over x is 0, so 0. 0 over 0, L'Hopital applies. We take derivative, negative cosine x. If we take derivative of that, that'll be just sin x over 1, and sine of 0 is 0. So limit as sin x over x, limit as x approaches 0 of sin x over x is 1, and limit as 1 minus cosine x over x is 0. And you can find both of these by using L'Hopital's rule. Now that we know both of these, we can pull this sin x, and this x out. And then we have cosine over secant. Cosine of 0 is 1, so we have 1 on the top. This is equal to 1 on the top. Secant squared x. So let's plug 0 in here. So 0 squared is 0. And secant squared x is 1 over cosine squared x. So if we have 0 here, just cosine 0 squared. Cosine 0 is 1. 1 squared is also 1. So just 1 over 1 on the bottom, which is also 1. So that's where he got this one from, and this is where the other one came from. 1 times 1 ends up equal to 1. Okay, so yeah, like what I did up here is I forgot to, what do we have here? Yeah, there's 2 and 2 need to cancel each other out first, and then this sin x. Okay, this is very wrong. This is very wrong work, but this 2 and this 2 can cancel out. Sin x and sin x can cancel out into limit as x approaches 0 of those 2 is just 1. Then we just have cosine over secant x squared. And then yeah, if you're doing L'Hopital's principle over and over again, and you realize that something's got to be wrong here, then you stop and you try to apply some trick identities, and it will work. And let me see if I can find the problem from yesterday. And see if I can find the problem from yesterday, and also show you how to do that. Problems from yesterday. Let me see which problems we did from yesterday. Alright, we did one where we had to factor like x cubed. So these are problems that we did from yesterday. Alright. So let me just use some empty space over here. Okay. So this is a practice problem that we did from yesterday. Limit as x approaches 1 of x cubed plus 1 over x plus 1. Oh god, what happened up here? Plus 1 over x plus 1. Okay. From yesterday we learned that this is indeterminate. 1 cubed is 1. 1 plus 1 is 2. Why no? Oh, negative 1. It's limit x approaches negative 1. Negative 1 cubed is negative 1. Negative 1 plus 1 is 0 on top. Negative 1 plus 1 is also 0 on the bottom. So this is indeterminate. That means LHOP applies. Also, you gotta write. Let me show all the work. For this one because I have room. So we have lim as x approaches negative 1 of x cubed plus 1 is equal to 0. Lim as x approaches negative 1 of x plus 1 is also equal to 0. So that means you put 3 dots. You put 3 dots in a triangle, which means therefore LHOP P tau applies. LHOP applies. And then LHOP applies, so now you take the derivative, then you write limit as x approaches negative 1 of x cubed plus 1 over x plus 1. My pen's lagging, but this is just rewrite of the problem up here. That will be equal to limit as x approaches negative 1 of 3x squared over 1. And this is just negative 1 squared is 1 times 3 is 3, which is the same answer we had from yesterday. And the other problem, which is limit as x approaches 0 of square root of 2 plus x minus square root of 2 over x. Alright, because I already showed you a problem of where you need to use, where you can use conjugate, like what we did earlier. Instead of using conjugate, it's up there. But instead of using conjugate, we use L'Hopital. The same idea for this. But there is actually an easier way to solve for this, or any problem that looks like this, which I'm going to talk about in the next video, and that is the formal definition of a derivative. Thank you for watching.